Hey guys, welcome to the next video in my series where I'm breaking down every topic in A-level maths. Today we're looking at straight lines. This is going to include how to generate the graph of an equation, the equation for a straight line where we'll look at the y-intercept and gradient, how to work out the equation for a straight line through a specific point, the relationship between parallel and perpendicular straight lines. Then we'll finish off with some coordinate geometry where we'll learn how to calculate the distance between 2 points, as well as the midpoint between 2 points. Every section in this video is going to be timestamped, so you can easily skip to it if you'd like to. Hope you find this helpful. The first thing to look at is how to generate a graph from an equation. Let's take the example y equals x plus 1. We can assign the values of x and y to two different axes in a coordinate grid. Now let's create a table of pairs of x inputs and y outputs. To generate the corresponding y output for each x input, we use the equation which says to simply add 1 to each of the inputs. Now, if we plot these pairs of x and y values as points in our coordinate grid, we can see they form a straight line. The equation for the graph of a straight line can always be written in the form y equals mx plus c. We call m the gradient and c the y-intercept. Let's take the example y equals 2x minus 3. We can see this intersects the y-axis at 0 minus 3. Let's use the equation to see why. The graph intercepts the y-axis when the x-coordinate is 0. If we substitute this into the equation, we can see it produces a y-coordinate of minus 3. We can see if we set x to 0 in the general equation for a straight line, the corresponding y-intercept is c. We can see the gradient of our line is 2 because for every unit we travel down the x-axis, the line increases by 2 units along the y-axis. In general, the gradient of a straight line is the rise over the run. We need to be able to calculate the gradient of a line that goes through two arbitrary points in the coordinate grid. The run between these 2 points would be the difference in the x-coordinates. And the rise between these 2 points would be the difference in the y-coordinates. Plugging these into the formula gives us the gradient of the line to be y2 minus y1 over x2 minus x1. We need to be able to find the equation of a straight line that passes through a specific point. For example, let's say we want to find the equation for a straight line with gradient 2 that passes through the point 3, 2. First, we sub the x and y coordinates into the equation, and then we rearrange to solve for the necessary value of c. To find the equation for a straight line, we need to know the gradient and a point on the line. If we know the gradient, we just need to find the value of c. To do this, we do the same thing as a moment ago by plugging in the point into the equation and obtaining the corresponding value for c. Alternatively, we can find the equation for a straight line if we know 2 points on the line. We can calculate the gradient of the line using the coordinates of the 2 points. Then we would just need to find the appropriate value of c for our equation. We can do this by inputting the coordinates of any point we know lies on the line into the equation. We also need to know when 2 lines are going to be parallel or perpendicular from their equations. We can see that any lines that are parallel simply have the same gradient. The gradient of a perpendicular line would have the opposite sign gradient and be the reciprocal of the original. To summarize, if we have 2 arbitrary equations for straight lines, they will be parallel if their gradients are equal, and perpendicular if their gradients are negative reciprocals of each other. We need to be able to calculate the distance between 2 points in the plane. Consider 2 arbitrary points in the plane. We can calculate the distance between the points by constructing a right-angled triangle. The base of our triangle would be the difference in the x-coordinates, and the height would be the difference in the y-coordinates. Now, to find the hypotenuse of our right-angled triangle, we just use Pythagoras' theorem. Square rooting, we get the final formula for the distance between 2 points in the plane. We also need to be able to find the midpoint between any 2 points in the plane. Let's again take 2 arbitrary points in the plane, and we will call the midpoint between them M. Now, let's use the diagram we used in the last section again. To get to the midpoint from the first point in the plane instead, we just need to half the distances. So to get the coordinates for M, we can take the coordinates for the first point and add on the horizontal and vertical distances to the x and y coordinates respectively. To simplify, we can start by splitting the fractions into 2 fractions. x1 minus a half of x1 would leave us with a half of x1, and similarly for y. Now we can rewrite the x and y coordinates as single fractions, and we see to get the midpoint between any 2 points in the plane, we simply just need to average their coordinates. So that's the end of the video, guys. Here's a little summary of everything we looked at today. If you found this video helpful, please drop it a like, that helps me out a lot, and consider subscribing to the channel to stay tuned for when I release new videos. Thanks, and I'll see you in the next one.